Guys, welcome back, and today we're going to be doing free radical substitution. And so what does this actually mean? Let's break down this term. So first is free radical. We need to define what a free radical is. And a free radical is when UV light breaks apart a bond. So you have, let's say, a Cl2 bond, and you have UV light that comes in, breaks this bond, and gives away its two electrons. So remember, every covalent bond is made up of two shared electrons, and I'm gonna show them as an X and a dot. And this electron goes back to this chlorine, and this electron goes back to this chlorine. And you see the half arrows that I drew that shows that only one electron is moving, as opposed to a full arrow, which would mean that a pair of electrons are moving. Here, what basically happens is it forms two of Cl radicals, and these radicals are formed because, remember, Cl has a proton number of 17, as you can see from the periodic table, and that has a structure of 2 electrons in the inner shell, the first shell, 8 electrons in the second shell, and 7 electrons in the third shell. 1, 2, 3, 4, 5, 6, 7. And this 7th electron is used in covalent bonding. And when the covalent bond is broken, like over here, what happens is it doesn't return back to its original position. It actually waits over here, very far away from the inside of the nucleus, because it would rather wait outside and be reactive and react with other substances than go back to its shell and lose energy. So what basically happens is this Cl radical is a very reactive substance, because remember that the reactivity of a substance is based on its ionization energy, and the ionization energy of this chlorine radical is very low because the electron is already very far away from the nucleus. And this results in a free radical substitution. And the second part of the term is substitution. And what that means is basically when you have an organic compound, let's say methane, for example, you have CH4. It meets one of these radicals. So let's say it meets one of these Cl radicals, chlorine radicals. And what happens is this is a reactive species. So what it does is it attacks this hydrogen, and it basically rips apart the hydrogen from the carbon, and so the hydrogen gets back its electron to form a bond with the chlorine. So it goes to HCl because the electron is returned to the hydrogen. So it's basically H plus Cl. So it goes to HCl. And so this means that the original methane molecule is now, the original methane molecule is now losing a hydrogen. So what it forms is another radical, because remember there are two electrons in this bond here. So the other electron gets returned to a carbon, and this forms a radical that is like this. This radical here is also very reactive because it has an electron very far away from its nucleus. And so this reacts with chlorine molecules this time. Let me draw it out. So this reacts with chlorine molecules in the mixture that we said earlier. And this would cause, let me rewrite this chlorine molecule like this. So what this would do is it attacks this chlorine molecule and it breaks apart this bond. So we have two electrons here. So this one gets its electron and this one gets its electron. and what we get ultimately is the Cl bonded with the CH3 radical. So we have C, and then we have H here, and we have H here, and then there's a Cl here. And then remember, this Cl has one electron in its very far from its nucleus because it gained an electron from this breaking of the bond. So it's also a radical now. And this radical is the same as this one here. So there's a chain reaction that occurs because of this, and this keeps going until there's a termination reaction. And termination is basically, oh, I forgot to mention that all these steps that we just saw is the so the initiation is the breaking of the Cl bond. Initiation, the breaking of the Cl bond to form radicals, and the this step is the progression step. So this is here, progression. The last step is termination, which involves two radicals reacting with each other. So let's pick an example. So we have this radical here in our mixture, and also we have the Cl radical. So we can combine those two, and we have C radical with 3 H's plus a Cl radical, and these react by forming a covalent bond, and it forms CH3Cl. And you can see that CH3Cl is also formed in the progression step as well. And so this is the primary product of this reaction, because there's two of them, one here and one here in the termination step. And so you can figure out the primary product by looking at which molecule is produced both in the progression step and the termination step. And so when you come across more complex questions like, let's say you have propane. Propane, remember, is 3 carbons because prop is the prefix for 3. And we have 8 hydrogens attached to these 3 carbons. And let's say we want to react this with Cl2 in terms of in a free radical substitution. And what could happen is the Cl could replace this H, this H, this H, this H, this H, all of the H's in the same proportions. So if the exam might ask you, let me write it down. What is the ratio of, let's see, 1 chloropropane, 2 chloropropane? And it's not 2 to 1 as you would think. Like, there's 2 C's that are 1 and 1 C that's 2, so it's 1 to 2, but it's not like that. You have to look at the hydrogens that are bonded to the carbons. So there's 3 hydrogens and 3 more hydrogens that could be considered carbon 1. So we have 6 hydrogens, 6 hydrogens for 1, and only 2 hydrogens, which are these ones, 2 hydrogens for 2. And so the ratio is 3:1, because 6:2 is 3:1. And the important bit is they have to say in excess excess propane, because if it's not excess propane and excess chlorine, then that would result in double substitution. For example, a Cl here and Cl here, and that would be 1,2-dichloropropane, and that makes things complicated. So this is basically the simple version of a question they might ask you. And so yeah, that's pretty much it. This is how you would explain free radical substitution, and also the normal way we write it is the structural formula. So let's say we have propane as before, so we have CH3, CH2, and CH3. So the structural formula, all it does is shows what's bonded to each carbon as a component, and we say plus Cl2, or in this case we would say Cl radical for the progression step, because we assume that the initiation is already done. And for example, we could get 8 CH2 radical, CH2, CH3 plus 8Cl. Or we could also get, the interesting part is we could also get CH3, CH radical, CH3 plus HCl. If you go through the same process as we did up here, you can see the mechanisms that make up this substitution, and you will see that there are two possibilities. They could go on the first carbon, or they could go on the second carbon. And this is what makes free radical substitution kind of confusing, is because there are so many possibilities for the chlorine or halogen to go. And so yeah, I hope that clears some doubts for you guys, and the next video will probably be on nucleophilic substitution. And yeah, thank you for watching.